Welcome back, friends of the channel, and I'm excited because Fidelity FX Super Resolution 2.0 is finally here. It's been teased all year long, but I've now gotten to take some time and test it. And today I'm going to go through and explain how Fidelity FX Super Resolution 2.0 or FSR 2.0 works and how it's different from FSR 1.0. I'll also discuss graphics cards compatibility and why it's not quite as simple of a discussion as with FSR 1.0. Then I'm going to take a look at how well it works using the game Deathloop as a point of reference. And for the finale, I'm going to find out if and how well FSR 2.0 works on Valve's Steam Deck. Well, now that you know what's coming, let's jump right into it. So to understand why FSR 2.0 is a drastic improvement over FSR 1.0, I'll need to do a bit of a recap on the original. You see, FSR 1.0, as good as it is just a spatial upscaler. That means it takes a lower than native resolution, so a 4K image would actually be rendering at 1440p, and uses an advanced upscaling and sharpening technique to attempt to make the image appear as close to native true 4K as possible. Another component that makes FSR 1.0 great is that the processing is done in the middle of the render pipeline, so the post-processing effects and heads-up display elements remain at the full crisp resolution. But spatial upscaling can only be so good as it works off a single image and tries to clean it up. That's where FSR 2.0 comes in and steps up the game in a big way. It still takes place in the middle of the render pipeline, but this time it's using a temporal upsampler, much like NVIDIA's DLSS. Okay, cool. What does that mean? Well, there's a lot more here going on, and actual temporal reconstruction is taking place. So basically what that means is the game still renders at a sub-native internal resolution, but uses multiple frames and motion vectors to rebuild the on-screen image to as close to native. And what's really cool about FSR 2.0 is, just like FSR 1.0, it's compatible with a wide range of graphics cards due to it not relying on machine learning or dedicated hardware for this procedure. And just like FSR 1.0 and other upscaling reconstruction techniques like DLSS, FSR 2.0 follows a general table of scale factors. Quality mode aims for a 67% internal resolution, balance runs at a slightly reduced 59% scale, and performance is 50% scale. So, quick numbers for a 4K render target would have the internal resolution for quality at 1440p, balanced at 1270p, and performance at 1080p. With the added compute cost of processing multiple frames and motion vectors, there will be a performance penalty when comparing the older FSR 1.0, and that's to be expected. Because of this, AMD actually recommends particular cards for various target resolutions, something that wasn't really done with FSR 1.0. For example, at 4K, AMD recommends a Radeon RX 6700 XT or an RX 5700 and above. On the GeForce side, because yes, FSR 2.0 is vendor agnostic, the RTX 2070 or 3070 and above are recommended for 4K. At 1080p levels, the RX 6500 XT or the GTX 1070 and above are recommended. Now in just a moment, we're going to see how much of a performance difference there is for running FSR 2.0 versus 1.0 with a Radeon RX 6700 XT at 4K. But before we talk about performance on desktop cards, we need to talk about visuals, because it doesn't look good, then, well, it doesn't matter how much faster you're running, does it? Well, AMD provided a code for Deathloop so I could get a good look at FSR 2.0 in action, and that's what I'm using today. Unfortunately, right now, it's the only game that supports it, but I will be testing future games, so be sure to subscribe here at PC World to catch those videos. And kicking things off with a native to FSR 1.0, we can see a very clear degradation of the image, even at quality mode. The power lines and the balls that are suspended from there are much softer and shimmer now. The rooftop railing has become quite fuzzy, and the sign above the door has degraded quite a bit. What about when you switch to FSR 2.0? Well, admittedly, this is a temporal solution, and standing still like this will generate a slightly better image than when in motion, but for example's sake, this will do just fine. What you see here is a clear improvement over the older FSR 1.0, with the power lines now being solid, and the lines connecting the hanging balls are clear and defined. The railing on the rooftop is very sharp, and the sign above the door is no longer flickering. A massive improvement, to say the least. So then what about performance? Well, to get an idea of scaling, I used my X570 test bench with the Ryzen 7 5800X, 32GB of DDR4 3600, and a Radeon RX 6700 XT. Testing was done at 4K Ultra settings, but no ray tracing. Obviously, native gives us the worst performance of the bunch at only 43 FPS. Basically, every setting, whether it's FSR 1.0 or 2.0, will allow us to break that 60 FPS mark, which is great. But remember how I said FSR 2.0 is more intensive than FSR 1.0? Well, the 10 FPS in performance from FSR 1.0 to 2.0 and quality mode is pretty stout. It is still a drastic improvement over native though, and not to mention the fact that FSR 2.0 looks so much better, I'd say the performance differential is more than worth it. Now, these upscaling techniques always shine brightest on a big 4K panel with tons of pixels to work with. But what about something like the Steam Deck? I mean, FSR 2.0 is in the game and not the hardware, so why shouldn't Valve's handheld be a good fit for the performance-enhancing drug? Well, I decided to test that. After booting up the game, I noticed the option is in there, so I couldn't resist giving it a go. Now, one thing to remember with FSR, if any variety, is that it's going to render a lower internal resolution and work with that. And the Steam Deck is already at a low 1280 by 800, so I wasn't expecting miracles, and even with the quality mode, we're talking about an internal resolution of just a hair under 540p. On top of that, scaling up of the footage to fit on this 4K presentation, well, it doesn't look fantastic, but I promise you, it's not bad in person. So how did it go? Honestly, at first, it didn't seem like it moved the performance needle a whole lot. Well, at least performance didn't improve much. It did smooth out the frame rate, so it makes a difference that you can feel, but the most impressive part was how it smoothed out the jaggies. I wouldn't recommend running below quality setting here, as you're not going to get enough of a performance jump. I'm talking literal single digits worth of improvement, which is hard to actually measure. So go for the visual fidelity. When you're looking at scenes where there's severe aliasing at native, you'll find that FSR 2.0 quality smooths things out nicely. So what are my thoughts about FSR 2.0? Simple. It's great. It's a very good update to the Fidelity FX suite, and at 4K it's simply incredible in Deathloop, and even more impressive in what it can do with the Steam Deck. But this is just one title, and one that's been being worked on for a while with FSR 2.0. We'll definitely need to see more games, including ones that are developer initiated, to really see how FSR 2.0 holds up in the wild. But what about you? What do you think about FSR 2.0? Are you excited? What games do you hope get this feature integrated? Well, let us know your thoughts down in the comments section, and make sure you hit that like button and get subscribed here at PC World for even more PC hardware and software goodness.